Okay, so let's start with our next thing. So in last lecture or in last unit or last week, if you can say, what we have done is we have understood what is the need of a kind of this security, what are the meaning, kind of confidentiality, integrity, availability, so and so on, as well as what are the different active and passive attacks, and what are the kind of security protocol standards that will be there. So now, in this things, we are going to see certain classical technique. Now classical, it means that it will be used from, you can say, the starting it means even the Roman emperor Julius Caesar, kind of, that is developed by that thing, and they are going to use these techniques. So from that time, how the people are actually using the techniques, and the crypt analysis, it means what is the problems with the techniques. So this is what a kind of, writings that says are told that in every chapter they start with certain, kind of what we can say, the suvichar, the good thoughts, so and so on. So now we are going to see one kind of a technique, that is a symmetric encryptions. So as the meaning says, symmetric. Okay, so consider in terms of well, I will take the example of let's say I have given you one assignment, and two students are having the same assignment, same wording, same things, letters, everything. It means they are using the symmetric. It means it is a same copy paste. That is the way it will be there. So here in the symmetric encryptions, generally in the security we have a two entity. One is we call sender and one is we call receiver. So both of them are using the key, right? That is what we are using the word. So in the symmetric encryptions, we have a one key, that is, you can say, either a conventional key, a private key, or a single key. Now take an example of a room. For example, if let's say there are two students staying in a hostel, right? Hostel room. Let's say there are two students or three students or whatever. Now, generally, as you see that there is a one lock on a door. So it means everyone are having a same key. So that is what the meaning of a symmetric. So it means all of are having a same key. So that one can close the door, one can open the door. That's where the things will be there similarly. Okay. So of course, sender and receiver must have the same key. That's they are going to use it. So these are kind of a classical techniques, that were used very kind of starting. The people are actually directly or indirectly using these techniques. The reason is that I think those who have read the history, that there is a World War I, II. Before that, there is also a kind of a wars between the kings, so and so on. And now the people want to send a message, but they don't want that the enemy or the opponent will get the message. So what they have to do is they have to garble the message. Either they will hide the same message, simple message, in some pockets, and then through the courier or the person's messenger they will send it. Or if the messenger will be compromised, or the message will be taken from in a plain text, it will be available to enemy as it is. So that's why they are using the technique that will try to garble. Okay, so before going in this security things, we are taking certain terminology. The plain text, it means the original message that I want to send it. Okay, the sender want to send it to the receiver, and the receiver want to get the message. That is what a plain text. Now once the sender will convert those plain text in some garble message, right? So that is we call say as a ciphertext, and the ciphertext will be sent over the network, so that the once the receiver will get the ciphertext, using the key, receiver will convert the ciphertext in a plain text. So it's a very simple. A sender will convert plain text to ciphertext using the key. On the other end, the receiver who will convert the ciphertext to plain text using the key. Okay. So in terms of symmetric, both are using the same thing. Now cipher, it means whatever the algorithm that what we are going to use it. Okay. So you're transforming from either kind of a plain text to a ciphertext. That is what the thing is there. Yeah. So here in general, the name that is given of these ciphers, generally it is broadly classified in two things, N cipher and D cipher. So N cipher, it means you will convert plain text to ciphertext, and D cipher, it means converting ciphertext to plain text. Now how can you convert? Using the key. So in the symmetric key, as I told the room analogy, same key will be used by sender and receiver. So they will convert using this thing. Okay. So next thing is a cryptography. So it means whatever this encryption studies or methods that we are going to use it, that is we can say the in general the cryptography techniques. Now crypt analysis, that is what our next task. We will say that once we take one cipher, how to break the cipher. So it means crypt analysis. So that's where things will be there. So in this, once we see the ciphers, we will see that how can we try to break the ciphers, okay, using some of our advanced techniques or some, coding techniques or some kind of analysis of the message, anything that we are going to see. And if we combine this kind of cryptography and crypt analysis, it is, you can say, the cryptology. That is the word combinedly. So cryptology, that is what you can say, the kind of study of cryptography, as well as using the crypt analysis. We will try to break how these principles or methods, that's where we are going to use it. So these are certain kind of a terminology, that what is the meaning of what. And now generally when we study the ciphers, the algorithms, you can say, we are using these keywords, okay, this terminology continuously. So look at the generalized cipher model. So here you can see we have our plain text message. So for example, I want to send a message. So using the our kind of whatever the algorithms, okay, and this is what our key. So you can see key will be same at both okay, sender and receiver. Now this is what my kind of open channel, because as I told that we cannot go on putting a secure channel. For example, if I want to send a message from here to the my friend in USA, I'm not going to put a secure channel. Better that than whatever the key that we have preset, that's I'm going to use it, and I'm going to send it to the receivers. So even the one research area in the security field is that how you want to share the secret key, right? Because of course without sharing the secret key it is not possible. So are you going to send a secret key over the post, over the courier, over the phone, or over any other previously set up some media, so that the key will be pre-shared? So that is what one research area that is also going on in our field, that how a sender and receiver will do a prior key sharing. So it's like you can say username and passwords, right? So the passwords will be available with all the one preset, that is the it will be there. So once the key is available using key and the ciphertext, so this thing is there, then it will apply this decryption algorithms. So this is what our encryption algorithm, okay, and this is what a decryption algorithm, and then you will get the plain text, provided your key is correct. So if your key is not a correct, then there is no meaning, okay. Now one thing that is here, and that is also kind of, you can say, the required in our security field, that algorithm is available to everyone, right? So we don't assume that the algorithm is secure or algorithm is not known to anyone. No, algorithm is known to everyone. It's like our door lock in a room. So you can see door lock is available to anyone who is passing by, right? So but the key is not available. So that is what a technique here is, that the key that is with sender and receiver, every security lies there, that how the people are trying to take care of the keys, how they are going to secure their keys, remember the keys, or how they are going to, whatever the algorithm that they're going to use, how secure is that algorithm, because algorithm is known to everyone. So that's why by knowing algorithm, now we have to do the attack, that how the things will be there. Clear? So this is kind of general requirement. One is whatever the algorithm that's we are going to use it, that is secure. Now what do you mean by this strong? Generally if you will ask me the same question, sir, what do you mean by strong before 10 years? So I can tell you, fine, if it is secure on a Pentium 1 or Pentium 2 machines, at that time kind of that processor we have, I can say if that is kind of taking a much time, it is a strong. But if you ask me the same question now, I can say, well, it's supposed to be strong if provided if with Core i5, Core i7, and even with the kind of major, server things. If it will take much more time for attackers, then it will be a strong. That is the way it will be take to kind of doing the analysis of algorithms, okay, to find a loopholes in the algorithm. And of course the second thing is a key. So the key must be known to the sender and receiver, and whatever the key that is they are kind of get making, the key have to be not easily guessable. Otherwise sometimes you can see the major mistakes that done by the people is that they, due to either they don't remember the passwords, they are putting a passwords that is well easily guessable, either date of birth year or something, month, date, or vehicle numbers, or any other things you can take it, house numbers, pin code, or whatever you can say, that they are going to put it. So that is relate with that person easily and easily guessable. That is happen. But second thing is, if you put a strong passwords, if at one place it is fine, you can able to remember. But if there are 10 or 20 places you have to remember the passwords, it's again take a time. Okay, so this is mathematically, if we are saying that if we can give a key, that is our key, and that is our plain text, then we will apply algorithm. So you can say in terms of our language, C, C++, Java, you can say functions, right? So function name is E. What are the two arguments? There are two arguments. One is the key, one is the message. So once you give this thing, it will give you the Y. That is what our ciphertext. Now the decryption is also one kind of other functions, right? I think you people will realize this thing when you have to prepare your programming, right? So in the from tomorrow's lab, we are going to start your practicals. So with that, you will try to remember that you have to design the encryption decryption algorithms. That it will try to help you in that way. And you have to put these arguments, the key and the ciphertext. The moment if the key in ciphertext you will apply, you will get the plain text, the original message as it is. Okay, that is the way it will be there. Okay, so as I told that algorithm is known to everyone, right? The only thing is that the kind of a key that what we are going to use, that depends that how we are going to secure that things. Okay, so what are the kind of encryption operations we are going to use it in general? Substitution. What do you mean by substitute? It means with one letter you are substitute other letters. That is the way it will going to be there. Now second thing is transpositions. Okay, so it means you will change the kind of letters here and there, that whatever the sequence you will garble here and there. So like if I will take the students when they are coming in a class, all right, so it means they are sitting in a not in a roll number, they are sitting as it is. So that is what they are kind of one kind of a permutations. And a product it means that a combination of substitution and transpositions. So both if you are going to use, that it will consider as a product of the ciphers. And compared to the substitute and transposition, product cipher are more secure because they are using both the things. So they will make the message more garbled. The more and more message you will try to make a garble, it is hard for attackers to find out a loopholes and try to find out the key. That is the way it will be there. Okay. So the number of keys is either you can use a single key. In terms of our door example, either I can use a key to open the door and close the door. That is as of now. Or let's say the second methodology, I can use one key to open the door. I can use the second key to close the door, right? Now this things more in details we are going to see in your upcoming units, the public key, that is your unit 3, and the applications of this two key, that is what we say the signatures, the digital signatures, right? That's also we are going to use in your chapter, unit 4. That's what we are going to use it. So right now we are starting with symmetric key. Then we are going to move to the public key and with their kind of signatures. Okay, that is what we are going to use it. So that's defined in two things. One is either in terms of block cipher. Block cipher, it means that, for example, I think now all of you know in terms of a computer network. Let's say if I want to send a 1 GB file, will it my computer send 1 GB file at a time? No, it will divide my file in a packet size, right? Whatever the network protocol, they will divide and then they will send it. So this is what a block cipher. It means whatever your message, that is divided in some blocks and then it is going to be encrypted and it is going to be given. In stream cipher, whenever the bits are coming, they will start encoding the bits and then they are going to send it. So that's what it's going to be doing. And of course now the crypt analysis, it means in our language it is an attack, how we can try to do it. So whatever the attack that we are trying to do it within some kind of a smart techniques or a brute force. Now what is the meaning of a brute force? Brute force, it means that you will try all possible permutation combinations and dictionary attack. Dictionaries means the known keywords. Okay, so that is what you can say the brute force attack. So the naive attack on any system is the brute force attack, right? So that is the way they are going to try to secure the things. Okay, so of course if brute force is going to be satisfied, but time is matter here. Fine, I can give you the cipher, I can tell you fine, going to break it. You can say fine, I will apply the brute force. Okay, you can write a program, it will try all the keys, fine. But if it's like I'm telling you fine that your first exam paper I will give you before 1 month, right? Your first exam paper I will give you before 1 month, that is encrypted using some key. Now your task is to break it. If you're getting earlier before the exam date, it is advantage to you because you will get to know the questions. But if you are not getting the paper till your exam is there in within 1 month,
Will it be useful to you now? No, because on the day of exam, anyhow, you are getting a paper. So afterward, that message is not useful to you. Now, in terms of other thing, let me take you. Consider that there is a visit of certain higher officials. Either you can take the some ministers, PM, CM, or any other cabinet or so and so. If they are going to visit certain things or certain places, their schedules will be kind of a fix. Okay, but they are not going to out it easily that okay, this is what exact time they are coming, so and so on. And let's say that schedule is encrypted. Okay, now for an attacker, that thing is only helpful if they can attack before the visit is happens, right? After visit, there is no meaning. So that's why you have to make a system that you can claim that okay, fine, if the attacker want to try it using this brute force and so on, it will take this much amount of time. Then this is the way you can try to prove the security of your system. Okay, because you cannot try for 20-40 years. There is no meaning to do this thing. That is wastage of time, provided the message is also useful after 40 years, then it is fine. But even for 40 years you have to start running your machines and getting all the possible combinations and try these things. Okay, so what are the different attacks the people are getting? Now here, in terms of attacks, we have to assume that attacker he is having a certain things, right? We cannot assume that attacker is only coming with pen and paper and saying, okay, I have pen and paper, can you give me the message? I can give you the key. Every time it is not happens, we have to assume that the attacker having a certain capacity, something is available, right? So first thing is ciphertext. So in this kind of attack, we assume that the attacker knows the algorithm and attacker have a ciphertext, some ciphertext that is transmitted. An attacker will try to identify what is the plain text or kind of you can say the key. Okay, now in the second one, attacker have a certain known that okay, kind of this is what the plain text. Maybe let's say I will start always my message saying good morning, right? So with that thing, attacker will try to say that okay, the first message of Nishant is always a good morning. So I know a plain text, and for that I know the ciphertext. Can I get something better? Maybe the future message I am going to decrypt. I'm not sure that how many of you have read the history of World War I or II. I think if I'm correct, then in whatever that I have read in one of the war, I think in World War I or II, I think mostly in World War II, they have used the messages that is sent in a starting, because every day they have to change the key. Okay, and so the morning message, from that they have started that this is what their general message, and from that they have started this is what a kind of a key that they are going to use it next and next. So from that they get that okay, this is the way they are going to attack. I think the movie is also made on that concept. Anyone know the movie?
The imitation.
So this
The
Yes.
immigration.
Imitation Game.
Okay, yeah, I think yeah, that is correct. The Imitations Game. So that was a movie prepared, I think, on that. So in which hero is preparing a machines, and on that machines they are putting as a plain text, that a ciphertext, and try to get it using the machines. Okay, so good thing. In terms of a chosen plain text, so compared to the known plain text, what I will ask the users, let's say sender, that okay, I will give you this message, do the encryption using your key and give me the ciphertext. I'm not asking a key. Okay, I'm giving them a message. I will ask them, fine, using your key, and algorithm is of course available to everyone. So give me the ciphertext. So maybe here you can assume the receiver is also can be an attacker, because the receiver provided the receiver is having a here in symmetric the key is available. So that's why the system is maybe compromising that thing. So if attacker is not a receiver, then attacker can ask the users that okay, I will give you plain text, you will give me the ciphertext. From that pair, I can try to tell you what is the key. Okay, so you can see the more and more power we are giving to the attackers, and try to see that whether our system is secure or not. In terms of same thing, ciphertext. So maybe if I have recorded a ciphertext, because you are well aware that ciphertext available on open network, right? It means using the probing. I think I even the tools from your network practicals. I can use the Wireshark or any other things to probe in a system that are tapping, and then using that, and I will get all the packets that is transmitted. So from those packets, I will get those messages in, and from that I will ask the users that okay, this is my ciphertext. That's you have sent it. Now you will try to give me the plain text, because the sender is having the key. Also sender can try to apply the decrypt too, because the same key is used by encrypt and decrypt. So fine, the sender can also do it. or the receiver can do it, whatever you can ask. Okay, attacker can ask to anyone and they can give you the plain text, and from that ciphertext and plain text, attacker can try to guess that what is the things will be there. Okay, and the next one you can say it will be again a combination of, you can say, the plain text and ciphertext. It means either attacker will ask the give the ciphertext, ask from the plain text, or the attacker will give you the plain text and ask for the ciphertext. So whatever the attacker wants is, and even here attacker can ask multiple times also. Don't assume that attacker can only ask, okay, that one times I'm going to ask you, you have to give me answer. No, it may be multiple times, because ultimately using this thing, attacker can try to analyze the message, try to guess that if my password is or my message is correct or not, try to check it out. So this is what a kind of a, you to assume that attacker having a certain kind of privilege, of course, and then they are going to use it. So some more security in terms of unconditional. So it means whatever the, no matter what computer power or time you are trying here, time means in terms of years we are talking, many years, still you cannot able to get the message with whatever the brute force attack. That's what you are going to do it. And second thing is computational. So with a certain kind of resources, you will try to see that whether you are getting a message or not. So here you can claim that with this particular security level, whatever the that we have defined, that will take roughly this much amount of time. Okay, if someone is trying a brute force attack. So for example, if I assume that my password is of a 5 characters, then I assume that what are the all possible combination of a 5 characters, and whatever the time required to test one particular password, if it will take, for example, 10 seconds, then if I have a 1000 or 1 lakh whatever the passwords, this much amount of time, by that maybe attacker will get the particular passwords. Okay, that is the way. So that is what a roughly kind of a computational security. So this is what in terms of brute force search. So here you can see the key size. Okay, so if my key size is, you can say, the 32 bit or 56 or so and so on. So more and more I will go deep down. You can see the moment if I go with, I will say that okay, the key size is, for example, 32 bit. It means what? How many possible keys is there? 2 raised to 32, because these are binary bits, right? That 0, 1, 0, 1. So I have 32 raised to 32 bit possibilities. And if for one particular decryptions kind of I have this much time is required, then accordingly one decryption per microseconds or 10 raised to 6 with advance, you can say, then even in that case with 10 raised to 6 decryptions, this is the time. And if I go down, you can see this many years, and this is not a small years, that you can see. Okay, so but what is the disadvantage if I increase the key size? Anyone tell me? Advantage is fair enough that if I increase the bit size, my security will be more. But what is the disadvantage of increasing the key size?
Message size would be more.
Yes, Kunj, you have raised the hand. Okay. Let me see who has raised the hand. I think someone. Let me see. Just a minute. Who has raised the hand? Yes. Okay, Atirya.
Encryption time will also increase as the algorithm reaches the order of n square.
Well, it is, I can say, correct in a notion of a time is increased. Okay, complexity will be generally remain same, but you can say if I will multiply two 56-bit numbers or do some operations with the 56 bits with other 56 or other bits, because I have to multiply or I have to do some operations in encryption and decryptions. So that time is taking more. Okay. So that is what you can say. Sometimes that's why in your languages you can see that you have an integer, you have a sort integers. That's why they are using. And roughly, if you are going to use in with a resource constraint, this thing is required. So the answer is correct that with increasing the bits of a key, because we have to use certain operations with a key, the functions that we have to apply, right? So that function will taking more time to compute. Okay, that is what the thing is there. Clear? So brute force, it means it is a most basic attack. You have to try all possible keys, and of course one key is going to be always be success. So if you are lucky, your key will become first, best case. If you are not lucky, your key will become at the last, or in that way. So that is the way it will be there. Okay. So now we are going with kind of a classical substitution ciphers. So what we have is there, we have a kind of a plain text with some letters and numbers and symbols, and we are trying to, going to use certain things and try to change it, that thing. So we start with the first one, that is, we can say the Caesar cipher, and that is actually used by the Julius Caesar, who was a Roman emperor, right? I'm not remember which one, 1, 2, 3, 4. I think there are some multiple Roman emperor, Julius Caesar. Caesars are there because I think they have a convention to give their 1, 2, 3, 4 name in that way. But I think they are using this Caesar cipher at that time, and at that time it was a success actually. You can see that the people are using Caesar cipher. Nowadays, if I'm asking you to use Caesar cipher, you can say how it is easily breakable. That is the way it will be there. Okay. So this is one kind of a substitution cipher by the Julius Caesar. Okay, and of course they are using in a military affairs. It means you can say that I am as a emperor is sending their troops a message using this cipher techniques. That's why they are going to use it. So what the technique they are going to use it? Replace each letter by their second letter. Okay. So for example, you can see one example. So this is one message. Meet me after the toga party. Okay, that is what just a sample message I want to send it. Now every letter will be replaced by their next two subsequent things. Okay. So after M, if you can see, oh sorry, okay, I think this, yeah. So after M, N, O, P, say this is our ABCD. So after M, the second letter is 1, 2, and then this is the P will become. Okay. So by adding a 2, N and O, the P will be coming in that way. So what, sorry, I think second or third letter, what you can say, I think there is second or third letter.
So this is the third letter.
Wow, very good. Congratulations, you have found first mistake. So this will be actually a +3. Similarly, you can do +2, +5, anything you can do it. That is fine. But ultimately, what is the concept? Whatever the letter, you have to add a certain number. Now, for each letter, you can see here for each letter, you have to add a 2. Like here for after A, sorry, 3 you have to add here. So after A, you can see B, C, and D. So the D will become here in the picture. So for each letter, you have to add a +3. Okay, that is what the here concept is here. So what is my K? Okay, so in general, if I write this is my K equal to 3, so that is my K, right? So it means whatever the message I am getting, I am going to do it. Now, how to write a program for this thing? Just a random question. Input, you are well aware. Input is a character array or a string. That is my input. Okay. The space, we are going to ignore the space. We are not going to add into this thing. So assume whenever the space is there, you will ignore the space. But for other letters, okay, and assume we have only the letters here. We don't have a numbers. If there is a number, then again we have to go to the ASCII code, and that we can try it. But as of now, assume that we have only the characters. Okay. And we are going to add that thing in that. So how to write a program in that thing? Input is string, output is a string. That's you are well aware. So my encryption functions will take two things. One is the key and one is the message. Okay. So here this is my X, this is my K, and I want to write E of KX. How can I do it? Okay, let me go to the white screen. So just for one cipher I'm going to tell you, or I can try to give you in detail. For other ciphers, fine, we can going to understand. So okay, fine, this is also fine. This is what we want to make it. Okay, so this is my functions. So what I will write here? K means the key. So in our case, K is equal to 3 and X is the message. What I will write in the function body? Of course, I have to return something. So let's say I will define some Y here, character Y I will define here, and then I have to return Y here last. That's I will try to do it for you. Y is also a character string. That's you are well aware. X is a string. Y is also a string. But how to convert using kx in y? What to write? What I will write. Okay, for in terms of our language, fine, you can assume here actually in example they have convert small letter to capital letters, but assume that X is also already in a capital letters, right? Message. Because I think we are dealing with ASCII numbers when you are working on a programming language. So for our best understanding, assume that all my message is also in capital letters. So the Y, that is my output, that is also in capital letters. Okay. So what I will write in a function body? What do you say?
First, we will iterate through each character, then we will get the ASCII value of each character in the loop and increment it by ASCII value 3. And again, we will convert ASCII to character and retain the character, and we will append the string one by one.
What is the sentence I will write in a coding?
Okay, sir. Okay, first let's define a for loop. Okay, for I in the Y.
I in Y or X?
Y we have already defined.
Y we have defined, but Y we have to calculate. So I think we have to follow the length of X.
Okay, let's assume Y is equals to X.
For I is equal to 0 to length of X. So that's for loop I have started. So now what I will do?
Now I will define a random variable, let's say T. T is equals to get the ASCII value of I, which is character. Obviously I is a character, so we will get the ASCII value of it.
Okay,
now,
ASCII value of what? X or what? X of I? I think X of I we have to get it ASCII value if you want.
Yes. Okay, then we will increase the T by 3 times. 3.
Okay.
T is equals to T plus 3.
What I will see?
T.
Okay, T equal to T plus 3. Okay.
Yes. Then I will define an array at the up. Okay. Above the Y, I will define an array. Above the Y.
Y of I.
No, sir. Actually, remove this line. I am talking about Y in the loop. Before the loop, I will define an array.
Okay, I think one good thing here is that we don't have to use the ASCII functions. By default, the character is always be ASCII value. So what we can do is straight away, if we can write Y of I equal to X of I plus 3, will it be fine?
Yes, sir. If it's available, then it's fine.
Will it be fine? Just I will write, for example, my X of I is capital A. Okay. So capital A plus 3. So it is by default doing additions with ASCII. That is whatever the ASCII value of A. There is implicit conversions, and then they are going to edit. So ultimately here B, C, and D. So that is what the things I am getting. Is something I am missing here, or fine the additions is enough?
Yes, sir. Sir, what if the characters are X, Y, and Z?
Wow, very good question. Good. What if my characters are X, Y, Z? So that's why I'm asking. I missed something here. Something is correct. Something is missing. That is what my thing.
Then
I'm not saying it is wrong.
Condition.
No. If do we require if, or we can use something else?
Module.
Wow, very good. What module? I will do it.
Module 26.
Good. Module 26. Very good. So we have total 26 letters. So 0 to 25. That's you will say. So whatever the number, 0 means here A, B, C, and so on and so on. So whatever the numbers, we will do the additions, and then we will go with the module 26. So that we have 26 provided here. The 0 will represent to the particular A character. Okay. So that is the way. Good. So I think you got somewhere a kind of okay, pointers of the. So that is correct. So this is what you can say. That's first they have consider transformations, because we are doing a plus 3. So that's you can see, and now you can see the XYZ that is convert in a ABC, because it is a round again coming. That is the way. So this means you are giving some numbers mathematically. So let's say A will start with 0 and Z will start with 25. So if in your whatever the programming language that you are using, if A will be defined at some other number. Accordingly, you have to change the modulo or something, that logic that you have to change. Otherwise, if your A will start with 0, you have to continue with that thing. Okay. So now what is my functions? Whatever the message I am doing, additions, that's how to do a modulo 6. What about decryptions? Encryption we have done, we have converted our message in some ciphertext. Now my task is for a receiver. A receiver also having a k equal to 3. So how can I write a decryption? Yes?
P minus K mod 26.
Wow, that's exactly correct. Good. I think you people are, become a ciphers, developer soon. Good. So this is what a message. We again go with the, C minus K with whatever the modulo 6. That's what we are going to use it. That is the way it will be there. Okay. Now the question is, if, for example, let's go to the previous slides. Let me try to erase the links. Now we will go with the crypt analysis. Sorry. Yeah. So consider I will give you just a ciphertext. P double H W P H D I W no H U and something. Can you give me plain text without knowing a key? How can you do
Yes,
it?
sir. Sir, it will only
Yes,
take
sir.
maximum of 26 attempts.
26?
Attempts, sir.
Well, okay. 26 or you can say the 25 because 0 if you add, ultimately you are getting the same message and that's you can able to easily see that it will be, not a plain text. So good. So in 25 attempts from adding 1 to the 25, right? What 1 you will add, then 2. So ultimately you have, considering a 0 also, you have total 26 plain text. Now from that 26 plain text, you have to see that whatever, according to dictionary or according to whatever the message, just by looking at the message, you can tell easily that this is what the exact message is there. So now you can see that at that time, when Julius Caesar is emperor sending a message to the military things, it is a secure cipher. Nowadays, this is not a secure. Just using our language programming, you can write a functions decryptions, generate all the possible 26 possibilities, including that 0 and all the 25. Total 26 plain text you have. Out of 26, the one is going to be correct according to the grammatical and the dictionary things. Simple. So this is what a crypt analysis of a Caesar cipher, right? Okay. So
Sir,
yes.
Sir, 26 attempts for one character. Na?
26 for all the things, all the entire message, because let's say if you are doing, for example, -0, -1, -2, then you have to do for all the characters. Then you will get the entire plain text, different, right? Are you got it? It means I am telling that this decryption functions, I have to run total 25 times. 0, I think fine, I can try to ignore. So the decryptions function I have to run 25 times, considering k equal to 1, k equal to 2, k equal to 3. Okay. So every time you run the algorithms, you will get a one tentative plain text. Okay. Either it can be a correct plain text, or it cannot be a correct plain text. Okay. Sir, I think I'm getting a voice from your side. Okay. Okay, so I think now we will know that using just kind of a 25 attempts and considering, provided sometimes people are too lazy that they are considering 0 as their key, k equal to 0. So in that case, whatever your plain text, that's become ciphertext. Ciphertext become plain text. Simple. So with all the 25 attempts, you can generate the 25 ciphertext, and from that you can easily guess that which one is the correct one. So that's why Caesar cipher is nowadays people are not using, but this is just for your things that this is what one of the time this cipher is not breakable at that time. I'm not sure how the people are not thinking, because nowadays we assume that it is very easy. Maybe at that time that is not that much easy. That is according to looks, because if you are sending someone this message, it is purely a garble things to someone. If you are seeing ciphertext, what this thing is written there. So that's why maybe they are confused and they are not able to work out. Okay. And at that time maybe algorithms are not well known. That's I'm not sure. provided if one of the military persons of a Caesar or that who are using this N cipher D cipher, if that person is compromised, then you can say the cipher is going to be compromised. That is the way it will be there. Okay, fine. So I think with this, better to not start new ciphers, and I can give you your 5-10 minutes break in between so that you will be free. So I think now you people get to know that what is the cipher, what is the encryption decryptions, how to do the crypt analysis, right? Okay, so let me try to stop here for this thing. Other advanced ciphers we are going to discuss, from the tomorrow lecture. So that is again require somewhat more hard to break.